Then, after we're done with the warm-up, we'll take a look at Desmos because we really need to start using Desmos, and it'll make your life lots easier with today's assignment to be able to make use of Desmos. So Desmos is the calculator you'll have access to when you're doing the OST anyway, so you really want it to be your best friend. And we're going to start making it your best friend today. Then we just got an Ed puzzle that's nice and short. Hey, Angelina, good to see you. And an Alex assignment that's nice and short. So both the Ed puzzle and the Alex assignment are about function notation and evaluating functions. We haven't even formally defined functions yet. We will likely be doing that tomorrow, but just the basic function notation and how you evaluate a function is what that Ed puzzle analysis assignment are all about today. And the evaluate part is why I'm trying to pull Desmos in with this. So here we go. If we go to the next slide, this is a little bit to try and remind us about the coordinate plane, but the quadrants, we aren't really dealing with them today, but just realize that we got 4 quadrants. You start with the top right one, and in Roman numerals, we call it 1 for the top right. Go in counterclockwise order, 2, 3, and 4. This is what we're about to do, but I'm going to do it somewhere else. Since my tablet has been such a royal nightmare in terms of pauses along the way, I got to thinking maybe I should try Smart Notebook. Hey, Dion, good to see you, man. So, very quickly, just looking at the coordinate plane, why don't we start out with the kind of simple reality that what we have here is the x-axis going from left to right. This is my x-axis. You see the label right there. And then the up and down axis, of course, is our y-axis, labeled y right there. And where those two guys cross right here in the middle, that's our origin, 0, 0. While we're having fun making sure we know the basics of the coordinate plane graph, where they cross, if it's 0, 0, then this would be 0. And of course, halfway between 0 and 2 would have been the number 1. And then 2, this line would be 3, 4, 5, 6, 7, 8. Likewise, on the negative numbers, this would have been -1. We got -2. The next line would be -3. So they just only numbered the even lines, just so you don't get all mixed up seeing the numbers smashed together. But that gives you a little more. It would be the very same idea on the y-axis. Positives going up, negatives going down. So, any questions there? I'm getting the no. Gee, thanks. I have the question at the moment, what in the world is set notation? And just a reminder, it's these curly Q brackets, and in Alex, they give you a button. That's really crummy attempt at making them, but that's what it means by set notation. Those brackets mean here's a set of numbers or a set of ordered pairs. All right, so moving right along, there are at least 2 ways to think about identifying an ordered pair to name the location of a point. One is to count left and right. So that's kind of why I've got this here. The first number is your x value, and it's a left and right. So one way to approach it is to count. You start at the origin and count however far left or right you have to go. So if I'm going to do point A, the only reason for my plus and minus signs are a reminder. If you're going right, well, you're counting a positive number. If you're going left, then that's going to end up being a negative number. Likewise with y, it's your up and down number. Up would be positive, down would be negative. That's all kind of obvious because if you start at the origin, well, that's all positive numbers to your right. If you start at the origin, that's all negative numbers to your left. Let's do our left-right number for A. Starting here, I have to go 1, 2 to the right to get even with A there. So Ordered pairs do require parentheses. So the first step is draw my, well, the first step is get frustrated, parentheses, 2, comma, and then I got to count how far up or down. In this case, it's up 1, 2, 3, 4, 5, 6, 7. Notice I didn't start counting 1 until I left the axis. This is the 0, then it's 1, 2, 3, 4, 5, 6, 7. Okay, so that's one way we can count. Both of those numbers happen to be positive numbers because I went right and then I went up. Another very helpful way to do it, besides counting like that, is just to see, all right, if I want my x value, what is my point even with on the x-axis? So I can simply do that, and clearly a is even with the number 2 on the x-axis. And then for the y value, well, what number on this y-axis is my point even with? And clearly it's between 6 and 8, which means it's the number 7. So either of those ways, counting from the origin, 1, 2, 1, 2, 3, 4, 5, 6, 7, or just going to your point and figuring out what it's even with on each axis. Either one of those will get you a good answer. So I'm going to run through B and D, but then we'll take a little bit closer look at E. And if you've got questions about B or D, please ask. B is over here at -4, +6. So an x value of -4, a y value of +6. D is down here with an x value of -3 and a y value also of -3. So -3, -3. Then when we get to E, it's still the same idea. It's just that sometimes when we're on an axis, people get frustrated or confused or something. If I do it the counting method, going left and right, I'm going to go nowhere left or right. All I have to do is go straight up. So the fact that I'm going nowhere would be a 0. So my first number, 0, and then I'm going up 1, 2 for my second number, so 0, 2. If I did it just trying to look at what am I even with on the axis, well, for the x-axis, I'm even with the number 0, so that's how I know x is 0. And on the y-axis, I'm even with that 2. So either way you look at it, 0, 2. Any questions there, guys?
Yes. Okay, so I have a question.
Malcolm put the nice curly Q brackets in the chat for us. Thank you, Malcolm.
Um,
I just
so
hold on just a minute. The set notation is those curly Q brackets that Malcolm put in the chat. Yes, sir, Malcolm.
okay, so sometimes I be seeing ordered pairs and the 0 comes last sometimes,
Yep.
and I wonder which one, or like
That means your
which.
y is 0. And so when you look at your y-axis, where am I 0 on the y-axis? Right here. So it means if the second number is 0, you could be anywhere over here. You just can't be up or down anywhere. So you're on the x-axis now.
Is the same for the other side?
Yeah, anywhere at this height, because the y-axis determines how far up I am or how far down I am. So when I see that my second number is 0, that means I haven't gone anywhere up or anywhere down.
My bad.
That help?
Yeah, that helps. Thank
It's
you.
an excellent question, man. It's so easy, yet it so confuses our brains because I'm on the x-axis, but it's y that's 0. And yeah, anyway, but that's the deal. It's another way to think about it is whichever axis you're on, it's the other letter that's going to be 0. So if I'm on the x-axis, that guarantees y is 0. And if I am on the y-axis, that guarantees x is 0. Oh dear. Julie, it's so sweet. Maybe I'm going to stop teaching today and just see what you guys have to say to each other so that I can, just be thoroughly entertained. course, then we may have to bring in the lawyers and stuff to deal with very unhappy students. All right. If we're all right with that E, and again, Malcolm, thanks so much for asking, man, because I'm sure you were not the only person with that good question. F is 7 to the right and 5 down, so that makes it a -5. So 7, -5. Close my parenthesis. The parentheses are just really important because otherwise you don't know, it might just be a list of 2 numbers. The fact that you see the 2 numbers in parentheses separated by a comma, that tells you, oh, it's an ordered pair of location on the coordinate plane. So G is our other problem for many people. We're not on any lines, and people just get so worked up and like, oh my gosh, there's no way to do this, but really it's not that hard. I'm smack dab in the middle of these 2 lines, so I'm gonna run right up there. Of course it won't cooperate. Mr. Reed trying to get used to using this. No! Okay, I need, some smart, really good person. There we go. Okay. So we're exactly halfway between 4 and 5. I have not yet made it to 5, so it can't be 5. It can't be 5 point something. I've made it to 4, and then I've made it a little further. One way to say it would be 4.5. What's the decimal version of 4.5 though? Anybody? Oh, thanks, Malcolm. Dang, Malcolm on it today. So 4.5 would be the x coordinate of point G. And then likewise, if I try and pretend that I'm super cool, man, then I can go straight over here to the y-axis and realize I'm between -3 and -4. I have not yet made it down to -4, so this would be -3.5 again, a 0.5 situation again. This time it's -3.5. Oh well, meant to do it in black, but I guess we'll just have to live. So if you just to emphasize it one more time, the x-axis is where all of these numbers came from. It's what number on the x-axis your point is even with. And the y-axis, these are all telling you how high or low your point is. So this 7, this 6, this -3, every one of them is telling you how high or low to go. Yeah, I'm hoping that helps a little bit. It's just, looking at it once doesn't necessarily make everybody feel like, gee, I've got it, but it's a start. Now, if you could do that warm up, if you haven't already, it's in Google Classroom or it's right here. And I'm even going to throw this link into our chat, but let's choose everyone first. Come on. All right. So this is just a Google form warm up, very similar to what we were just doing. There you go. So I'll even put the handy dandy timer up, give us no more than 5 minutes to do this. Colleen does most before, maybe used it some. We're just going to use it as a regular calculator today. When we get to Desmos, if you just go to desmos.com, we'll use other aspects of Desmos soon enough. But right now, when you get here, there's this big banner. Rather than bothering to sign in, if you just click this graphing calculator button on that big banner, then you're going to see this screen. All right, so I'm in Desmos, and I would encourage you to join me in Desmos. I'm going to do 2 problems, but just listening to Mr. Reed do it is not necessarily going to stick in your head. If you try and do it with me, you'll remember it a lot better. Just doing a couple problems isn't suddenly going to make it so you feel 100% like, gee, I know Desmos like the back of my hand, but we got to start somewhere. So here we go. We're going to put Desmos on one side of the screen. So I'm shrinking it down. And then we're putting this guy on the other side of the screen so that we can see these 2 problems. So the fraction issue, depending upon what calculator you're using, it may not deal with fractions. That's part of why I wanted to do this. And then the exponent issue. Those are kind of the two things I wanted to look at real quick. But what's wonderful about Desmos is I can type all of this, 2/3 times 12 minus 8 in, and it's just going to automatically calculate answers as I go. So the way you type a fraction into Desmos is you put a division sign in, and that would be the slash, the key that is on the left side of your shift button. It has a question mark and a slash on it. So the shift button on the right side of your keyboard, but it's just on the left side of that key. So where you see a question mark, that key is your division sign. I'm going to do 2, that slash button, 3, and it automatically made a fraction for me. I'm down in the bottom of the fraction right now, so either I need to click over here to the right of it or just press the right arrow to get out of the denominator and be able to continue typing my expression. So 2/3, well, while we got this decimal here, I'll just point out this circle that has that little fraction guy in it, that's a button so that you can toggle between having a decimal answer like what we see right here or a fraction answer. Okay, so that's the purpose of that button, to be able to go between those two representations. So now I'm going to go ahead and write the parentheses 12. The parentheses are one way to indicate to Desmos that I am multiplying. If I didn't put parentheses there, I would have had to have put an asterisk, one of these guys, which will automatically turn into a dot. Somehow you have to indicate that you're multiplying, and two numbers right next to each other will not do that. And then the last part you see right now, the 2/3 times 12 gives me an 8, but the last part of that expression is minus 8, whoops, which leaves me with a final answer of 0. Does anybody have a question there? So I could erase that and redo it, or I could just come down here and create another expression. So I'm going to go ahead and do number 2, 3/4 times -8. So I start out with 3, the slash button, 4, and then I got to find a way to get out of the bottom of that fraction. So I just used my right arrow again. This time I have a -8, so I got to do parentheses and then the dash button, which would be right next to 0. So -8, close the parentheses, and then I have to deal with this exponent too. So I've got several options. The option I'm going to use to start with is shift the 6th button. It's got that upside down V above it. We often call that the caret key on calculators. So you see it just put me up into the exponent. I can type a 2, but then just like the fraction, I got to get out of that exponent back to the regular level of numbers. So that's one way. Shift 6. What you're really doing is that upside down V, and it pops you up into the exponent. What I hadn't pointed out yet is down here in the corner, the lower left corner, you'll see a little keyboard. And if you click on that, then you've got number keys, you've got the operations, the equal sign. But up here on the left side of the keyboard, the upper right corner of that left side, you've got a button that'll just put an exponent 2 on there automatically, or a button that'll put you in the exponent just like shift 6 does. So either way, whether you choose to use this keyboard, and in some ways this is kind of nice because it's got all the numbers together versus on our Chromebooks, our numbers are clear across that top row. Sometimes that doesn't feel very convenient to me. Anyway, I'm going to hide this keyboard again, and I am now on a subtraction sign, parentheses, -8, parentheses, +3. All right, the answer is 59. And if I'm at all concerned, did I enter it correctly? That's what I like about Desmos. I can easily compare this 3/4 over here. Did I put a 3/4? Yep. Then it should be parentheses -8 to the 2nd power, parentheses -8. Yep. Then a minus sign, then another -8 in parentheses. Yep. Then a +3. Okay, I got it all. So that's really helpful with Desmos, is being able to enter it and see what you entered. Now, one last thing, you're going to be given functions that are like 2x minus 5, and you're going to be asked to evaluate them for a specific value of x. So putting in here 2x minus 5, notice it put something on the graph, but it's not giving me any numbers. That's not going to get you a number. The only way you get a numerical answer is if all you put in there is numbers. So if they said evaluate it when x is 4, then you would replace that x in 2x minus 5 with a 4. And now you see that everything is numbers. It gives you a numerical answer. Okay. You may have questions as you're trying to use Desmos. Hopefully that gets you started with it. Any questions at the moment? If not, it's that 3.5 minutes of Ed Puzzle, which you can follow that link from Google Classroom, and then 3 problems.